In this video, I will talk about linear equation in two variables. So the standard form of a linear equation is ax plus by equals to c. So the a, b, and c are constant value. What is constant value? Is a language that we use in algebra all the time. So constant value. So let's say 1, 3, 5, -1, -2, -6, they are called constant, which is just a number. So why do we call them a constant? Because 1 is always a 1, right? 1 is not changing. And then x are y, and they are variables because they are changing. So let me give you a couple examples of linear equation. So we can have 4x minus 3y equals to 12. So that is a linear equation. Or you can move the constant c to the left hand side. So x minus 3y equals to -4, or you can add 4 on both sides and then write x minus 3y plus 4 equals to 0. That's fine, it's linear. And then y equals to 5x plus 3. So this is called a standard form of a linear equation. In statistics, most of the time, you will have to write linear equation in this form. And this form, we will talk more about it. So the next thing that we would like to do is, what is a solution of a linear equation in two variables? So we have two variables, right? X and y. So the solution means I can find an order pair x comma y that satisfy the linear equation. So I have a very simple example for you. So we have x plus 2y equals to 4, and then I have 3 order pairs for you. My question is, which order pair is a solution and which one is not? Let's do the math. So this one is x equals to 1, x equals to 2, and then y equals to 1, right? You have to substitute or plug in this value into the equation. So when x is equals to 2, we write 2 plus 2 times y, which is times 1, equals to 4. Is this 2? 2 plus 2 is equals to 4, so that is 2. So that means the order pair is a solution of the equation because that fits into the equation. And then how about the second order pair? When x is equals to 3 and then y is equals to 2 equals to 4. So 3 plus 4 equals to 4. This is not true, right? So that is not true. That means the given order pair is not a solution. How about the next one? When x is equals to 10, y is equals to -3, that equals to 4. So we have 10 minus 6 equals to 4. So that is true. That means the given order pair is a solution to the linear equation. Oh, why do we use the word linear? Why is this a linear equation? Because y is raised to the first power and x is raised to the first power. All right, so that's why we call this a linear equation. And then why do we use the word linear? Because the graph, okay, which is what we are going to talk about later in this chapter, is a straight line. So the graph of x plus 2y equals to 4 is a straight line. So we have, do you see that I gave you 3 examples of linear equation? The graph of them is a straight line. So straight line, we call that linear. So that's the reason. On the next page, so what we are trying to do on the next page is, I gave you a linear equation and I have some proposed solution for you. What I want you to do is, which one is a solution and then which one is not. So simply just plug it into the function, right? So we have x equals to 5 and y equals to 2. So what we are going to do right now is here. So we have y equals to 2 equals to 2 times x plus 1. Is 2 equals to 10 plus 1? The answer is no, right? So that means this is not a solution. It is just that easy. When y is equals to 4, we have 2 times -3 plus 1. So 4 is equals to -6 plus 1. That is not true. So that is, they are not equal. So that means the given order pair is not a solution. How about 0, 1? When y is equals to 1, we have 2 times 0 plus 1. So this is a 1 equals to 0 plus 1. So this is true. So that means the given order pair is a solution. And then when y is equals to 2, should not move the picture around. So when y is equals to 2, okay, what happened? When y is equals to 2, we have 2 times x plus 1, so that is 2 equals to 1 plus 1, that is 2, so the given order pair is a solution. And then the last one, when y is equals to 9, we have 2 times 2 plus 1, so 9 is equals to 4 plus 1, 9 is not equal to 5, then this is not a solution. It is just that easy. You plug in the x and y into the equation to see if they fit. If that fits, that is a solution, otherwise not a solution. Okay, so let's do one more, because one example is never enough, right? Another equation, and I have some order pairs, so let's do the check. So when y is equals to 3, let's switch to another color. So when y is equals to 3, we have negative x minus 3, so we have 3 equals to 0 minus 3, so that is not true, so this is not a solution. Y is equals to negative 2, negative 1 minus 3, so we have negative 2 equals to 1 minus 3. Yep, that is right, then this is a solution. 13 equals to negative 10 minus 3. Nope, negative 13 is not equal to negative 13, so this is not a solution then. And then when y is equals to negative 2, negative 5 minus 3, negative 2 equals to 5 minus 3. Nope, that is not true, so this is not a solution. Y equals to negative 9, negative 6 minus 3, so we have negative 9 equals to negative 9, that is true, then the given order pair is a solution. Okay, so let's do a few more. So I have 2 more equations, and then you have to do the checks for me. So first one, let's do the check. So when y is equals to 5, we have 2/3 times 2 plus 2. So this is 5 equals to, this will be as 4 over 3, right? And then plus 2, put that in fraction, so that will be 2 and then a 6, right? So 5 equals to 10 over 3. Is 10 divided by 3 equals to 5? The answer is no. So that means the first order pair is not a solution. So this, not a solution. And then let's check the next one. When y is equals to 5, we have a 2/3 I think the reason I put that up, I think I'm not trying to play with the fraction. I think when I prepare the problem, I definitely make a mistake. So it is supposed to be 3 over 2. It is supposed to be a 3 over 2. So we don't have to deal with the common denominator. So this one, the first one, we already wrote it. I am not going to erase that. So the one we wrote here, because I wrote a wrong fraction when I was preparing the problem. Let's just do that again. So when y is equals to 5, we have equals to 3 over 2, and then times 2 plus 2. Yes, I'm sure that the problem was supposed to be 3 over 2 times x, because I don't want to deal with common denominators. So 5 is equals to 3 plus 2. So 5 is equals to 5. So that is a yes. So the first one is actually a yes. And then the next one, we have a 5 equals to 3 over 2 times 10 plus 2. So 5 equals to 15 plus 2. So that is not true. So the second one is not a solution. And then the next one, we have a 1 equals to 3 over 2 times negative 2/3 and then plus 2. So we have 1 equals to negative 1 plus 2. So that is 1 equals to 1. So this is true. Then this is true then. And then 11 over 2 equals to 3/2 times 4 over 9 plus 2. So we have 11 over 2. That equals to, so that will be a 1, 3, right? This will be a 1, 2. So we have 2/3 plus 2. So this will be a 3. This will be a 6, right? So this is 11 over 2 equals to 8 over 3. So 11 equals to 2 is around 5.5. And then 8 over 3, that is not equals to 5.5, right? So 8 over 3 is around 2.7. So they are not equal. So that one is, this is a no. Okay. And then the green equation, is the green equation a linear equation? The answer is no, because this is not a first power. So this is not linear. All right, let's do the check. So the first one is y equals to 4. 0 square minus 4, so 4 equals to negative 4, that is a no. And then 0 equals to negative 2 square minus 4, 0 equals to 4 minus 4, so the second one is a yes. And then the third one, y equals to 0, 2 square minus 4, 0 equals to 4 minus 4, the third one is a yes. And then the fourth one, y is equals to 3, equals to x square minus 4, so 3 is equals to 1 minus 4, the third one is a no. The last one, y is equals to 12, x is equals to negative 4 square minus 4, 12 is equals to 16 minus 4, that is true, so the last one is a solution. All right, so that will be the end of this problem. That will be the end of this video. So if you think my instruction is helpful, let me know in the comment section below. Please like, subscribe, and share the video for me. Appreciate your help. I see you all in the next lesson. Signing out for now.